So I'm going to pull up a really short slideshow here. So first and foremost, I want to welcome everyone to our industry day for 2021 for the Agile BioFoundry. And first and foremost, thank you for joining. I do have a synopsis of our agenda shown on the first slide, just to let you know that we want to give you more information about what the Agile BioFoundry is, give you a brief overview of our operation and mission, and especially know more about the capabilities that we have under our belt and working in ways that we may be able to work together in a collaborative fashion. So we have presentations that are focused on this as well to make sure you understand how to do that. And hopefully we can get something set up in the future. We also have some more information about how this has worked well in the past and how we can learn from interactions that we have right now with industry. And so hopefully that will give you some ideas and some possibilities for working with Agile BioFoundry and our capabilities in the future. Before we begin, there are a few housekeeping items that we wanted to go over, just so takes a little bit of the mystery out of our presentation format a little bit. So we are recording this presentation series, and we may use it later on, both internally or externally. And we think it will be useful in that regard, but we didn't want anyone to be surprised by that. We also have limited ability of attendees to turn their microphones on and off and cameras, but we'll be able to do that if needed. But we do have a different format for submitting questions for the panelists. So if you can use the chat function, we'll be monitoring that throughout the event, and we'll be able to get questions to the speakers after their presentations or in larger question and answer sessions using that chat feature. But we also wanted to introduce a more elaborate area within Zoom, which is called the question answer area. And if you have a question that you really don't want to be voiced to the entire community, but you wanted to know what the Agile BioFoundry thought about that and how their operation might be impacted by a certain activity, then please put it in the Q&A area, and we'll actively monitor that both during the presentations and later on and get responses back to you and keep up the dialogue. We are implementing a few really simple polls throughout the presentations today. The responses are anonymous and will be kept that way throughout. And the results, are either going to be used in guiding our presentations a little bit today as to how they might be best directed, or in the future in guiding activities that the Agile BioFoundry may most be responsive to industry needs. And so that's why we're doing these short polling exercises. But again, last and most importantly, we look forward to not only discussions today, but the potential for future interactions with you and the biomanufacturing community. So with that, I'm going to stop my introductory remarks and ask Emily to put up a first poll. One of the things that we're interested in is learning about, maybe I wasn't even sharing that. Was I even sharing my slides, guys? Oh.
No, wow. You weren't sharing any slides.
Okay, sorry about that. Just make sure this works. Okay, so I'll put that up later. Our first very simple poll question is just get a little bit more information about who is here today, how much do you know about the ABF, and whether or not you've interacted with us before. So this is just a simple yes/no response. Have you worked with ABF in the past or interacted with us in one of our events previously? And so if you had, please answer yes, and if you haven't, answer no. And again, this will dictate a little bit how we may approach some of our presentations. So thank you. Okay, how are we doing on responses, Emily? Are we close?
Yeah, I'll go ahead and end it. We have
Okay, thanks.
about 85%. Yeah.
Oh, great. Thanks everyone for responding. I was sort of remiss in introducing myself, but I'm Phil Lively from Argonne National Laboratory, but today, more importantly, wearing a hat from the Industry Engagement and Outreach team within the Agile BioFoundry. So Emily, if you'd be able to show those results to not only the rest of the people, but the panelists, then we can sort of gauge a little bit more how the presentation should be directed. So great, we have a lot of new people. That's wonderful. So thanks everyone, and we hope we can give you a real short synopsis and a tickling of what we do and how we can work more together in the future. Okay, so with that, I would like to introduce Principal Investigator for the Agile BioFoundry, Nathan Hilson, who will start with an operational overview and mission of the Agile BioFoundry.
All right, thanks, Phil. I'm not going to have access to the Q&A and chats while I'm presenting. So if the others want to monitor. Yeah, so welcome everybody to our Agile BioFoundry Industry Day today. It's fantastic that you all are here, especially people that maybe might not historically be as familiar with the Agile BioFoundry. So my plans for the next maybe 15 minutes or so are to give kind of a quick overview of the Agile BioFoundry. Clearly, we are not going to have enough time to talk through everything, and I'm happy to follow up, or we as a team will be happy to follow up with you if you have any other types of questions. As Phil was mentioning, I'm the lead PI for the Agile BioFoundry, and I'll be giving the overview. So the overall goal for the Agile BioFoundry is to enable biorefineries to achieve 50% reductions in the time it takes them to develop bioprocesses compared to the current average of around 10 years. And the outcomes of what we're trying to do is to develop and deploy technologies that enable commercially relevant biomanufacturing of a wide range of bioproducts by a range of industrial hosts. And our relevance is that starting this year, we will be a $30 million per year public infrastructure investment that really helps U.S. industrial competitiveness and enables opportunities for the private sector in terms of growth and jobs. And on this last point here, some of the things that we've been doing is trying to kind of position ourselves with the help of some analogies to the transportation sector. So I'd like to thank Katie Wozniak and Steffi Davison. I think Katie is on the call now. But for this kind of most recent iteration in our analogy visualization. So when the Agile BioFoundry was getting going, Lyft was doing a marketing campaign that largely had a map that looks like what you're seeing now, which has been further now adapted to the Bay Area regional transit map. So basically, if you're from or visiting the San Francisco Bay Area, this is going to look very similar to what the BART map would look like. And the way that Lyft was kind of positioning itself is it would say, sure, you might be able to take buses or the BART, subway to several different places, around the Bay Area. But where you actually really want to go to, whether it's home or work or to a restaurant, isn't exactly where that subway stop is. And that's kind of where Lyft comes in. So basically, you would get off of the subway and then you can take a Lyft to get that extra mile. And we thought that was a fantastic analogy for us, because how we see ourselves at the Agile BioFoundry is we are this public infrastructure investment that gets companies fairly close in biochemical space to where they want to go, but we're not telling them where to go. We're not picking winners, and then companies can use all of their own business intelligence to figure out where they want to go and retain all the very valuable last mile intellectual property to get to the destination. But if companies work together with us, they don't have to reinvent the wheel. They can get a lot of the way to where they're going just by riding on our subway line. That's kind of the analogy. Couple of other little terminologies that we'll probably be throwing about today. So we have these terms around beachheads and targets. So beachheads are very analogous to the kind of the subway stops. So they're kind of intermediates that kind of get you along the way to where you want to go in metabolic space. And oftentimes a given beachhead can basically serve as an intermediate to many different targets, kind of the molecules where you want to go to, your final destination, where you'd want to be going to. So that's kind of like a layer on top of this map. And then another thing to point out is just kind of like there's maybe multiple different subway lines in the BART system. We also have overlaid onto this map this concept that different host organisms are going to be taking you to different places in biochemical space. So that's kind of maybe the different colored lines. So maybe Putida is going to be taking you kind of up here at top right, and C-glut is taking you to top left. Another kind of concept that we might be talking about a little bit are these exemplar molecules. So while there's a wide range of targets downstream of a given beachhead, an exemplar is just one example of an illustrative target molecule. So that's another type of a word that we'll be throwing about. Now, this is all through analogy. It's all very abstract, and I hope it helps you wrap your mind around kind of how we're positioning ourselves. So again, we really want to help companies, quickly develop processes to get to these target molecules. And part of that is developing these subway lines, these host organisms, and part of it is developing high flux kind of routes through these given beachheads. Now, in terms of something that's a little bit more specific and actually biochemical, I'd like to really thank Chris Johnson for adapting this map that was originally developed by Sang-Yup Lee and his group, but kind of shown here some actual chemical names in blue types of coloring. We would be having our actual target molecules where we've been developing demonstration projects to get towards them. We have the green are kind of our current beachhead molecules, and then in gray are for example prospective beachhead molecule. So instead of looking like a BART map, the metabolic space is actually quite a bit more dense and more complicated. But this is kind of gives you a flavor for how do you kind of go from something that looks like this, like a BART map, to something that looks more like metabolic space. The other thing to point out here, I talked about the subway lines, the different host organisms, and maybe Pseudomonas putida can get you to the northeast, and C-glutamicum to the northwest on the BART map. But these are kind of these are our hosts that we've been working with in the Agile BioFoundry. And it's also just a kind of a super brief introduction to our tier system. So in order for us to even work on a given microbial host within our Agile BioFoundry, we really need to onboard them and kind of basically develop them to the point where we have a minimal set of tools that make them manipulable and cultivatable, those types of things. And that kind of those minimal requirements are really tier one. So kind of fundamental tools and information needed for any kind of rational engineering cycle. And then as you progress up at the tier levels, it's much more timely and costly to develop these capabilities, but they can really unlock some really powerful capabilities as well. So in terms of the hosts that we've been working with currently in the bacterial space, we have Cupriavitis nectar, Rhodobacter spheroides, and Clostridium longdalii. In the fungal space, we have Leucomyces starkii, Aspergillus pseudotarius, and Zymomonas mobilis. Now, those are just to tier one. Hosts that we've also further elevated to tier two would include on the bacterial side Pseudomonas putida, C-glutamicum, and on the fungal side we have Aspergillus niger and Rhodosporidium toideroides. So these would be our current subway lines, and maybe some of these are kind of maybe darker, thicker lines with more capabilities, and some of these other ones are kind of the earlier stage in terms of our developments. But I hope that's kind of helpful to people to see, like, are the hosts that we're working with the hosts that you're also working with. And we're definitely interested in working together with industry and academic collaborators to increase the number of organisms that we're working with. So if you don't happen to see your organism here, it's an opportunity for us to work together in the future. And I'll give you kind of somewhat of a timeline for how we see the expansion in the number of hosts that we're working with. Other things to kind of point out, and maybe I'll kind of introduce this going back to the simple map. You can imagine that if you're a city planner or a regional transportation planner, you want to figure out, okay, there's a whole bunch of potential new subway stops, maybe underserved communities these types of places, or maybe for the economy, you kind of want to know, if there's a lot of, people trying to access this point, maybe it would really increase the economy of the local, area if we introduce a subway stop there. But how do you actually decide where you're going to be siting that next, subway stop? So maybe if you're actually in transportation, you'd be looking at, transit flows, demographics, all the types of, regional economy types of aspects. Kind of the analogy for us is doing things like techno-economic analyses and life cycle assessments. And I think some of the really exciting things that Bruno Klein and Tatiana Benavides have been working on have been, how do you actually do these types of analyses, not for a very specific process or a very specific product, but how do you kind of do it to capture kind of the techno-economics or the life cycle, assessments of a general region of biochemical space. And that's how they've been kind of doing it through these exemplar molecules. So there's a lot of targets that you could be going after. Maybe that would be the analogy to a lot of potential restaurants you could be going after. But maybe instead of analyzing, every single possible target that you could access from a beachhead, just represent it in an exemplar. And I think this is really going to help us prioritize, going forward into the future, like where do we develop, our host organisms, our beachheads, our pathways to best serve and give the best access to opportunities in biochemical space. So maybe in the techno-economic side, you can kind of see what is kind of the incumbent, minimum selling price or market price for a given product. Given what we know about our bioprocess, where are we? Are we actually bioadvantaged? And then same thing can be true for the life cycle assessment. So in terms of greenhouse gas emissions, for example, how might we be doing relative to a fossil feedstock? So this would be some of the other kind of things that we've been working on to figure out how to cite like our next beachheads or choose our next host organisms. The general approach that we follow, we do kind of follow the general engineering biology cycle, going from design through build, test, and to learn, and then back into redesign. I already talked a little bit about some of the techno-economic and life cycle assessments, talked about some of the hosts that we're working together with in the tier system. And then I'll be talking probably after this overview talk a little bit more about some of the capabilities specifically around design, build, test, and learn, including scale up. So this is kind of generally the process that we're trying to use in our approach that we follow at the Agile BioFoundry. And this gets into a little bit of the timeline. So maybe when the Agile BioFoundry was first getting stood up around 2017, the average bioprocess might have taken about 10 years to commercialize through scale up at a cost of maybe around 100 million US. And in our first 3 years, the Agile BioFoundry, as we were kind of ramping up, we said that we were going to be operating with 5 hosts by the end of the 2022. So about a year from now, we'll be up to 15 host organisms. I listed 10 on the previous slide. And we do anticipate now that we've started to see some shaves off on the development time and the development costs. And where we kind of want to be after, say, 4 more years from now is getting up to increasing numbers of hosts. We're having some interesting discussions in industry and academia are really helping us think through this. But how do you balance going deep in a given organism versus trying to diversify your hosts? So in the transportation analogy, do you really want to work a lot more on developing a given subway line, or do you want to expand into more subway lines? So I think we're still trying to figure out, do we want to go this broad, or do we want to go a little bit more deep in some of our hosts? And it's by the end of our 9 years of our projects, which would be about 4 years from now. That's kind of when we see, if a company works together, with the technologies that we've developed with the hosts, with the routes through beachheads, that's really kind of help new companies shave off 50% of their process development times. Now, in terms of the actual task that we're doing, and we've talked about some of these things already. So we've talked about some of the techno-economic analysis, life cycle assessments, host onboarding and development. We'll see some more of the scale-up capabilities on a slide here in a few minutes. Phil was referring to industry engagement and outreach, which is really important, especially for events like today. We do have a regular management. And one thing I'll just kind of point out is that in our core engineering cycle activities, we do have folks that are working on kind of our core infrastructure. And we do have some people working on kind of the beachhead developments, as well as demonstration projects to kind of show that not only do we say we have these capabilities, we've actually used them, and here's what we've done. And a lot of these demonstration projects increasingly are actually just getting done in collaboration with industry or collaborations. So over time, more of our internal efforts have been focusing a little bit more strategically around these beachheads, and the demonstration project largely are starting to transition more to our collaborations. Just to throw up our organizational chart, just to point out, especially on days like today, we do have an industry advisory board that we meet with on a quarterly basis. But days like today, that's more open and inclusive beyond just our industry advisory board, are also super important for us to kind of get feedback, as well as just to understand and meet and greet and business development, try to understand who else could we be working with or helping or learning from. So that's why I kind of throw that up there. Now, another kind of key thing just to be aware of when we talk about the Agile BioFoundry is that we are distributed across the US. We're not just in one single location. But together we draw upon all the capabilities, the infrastructure, the domain expertise at 7 of our US Department of Energy national labs to form the Agile BioFoundry. And another kind of important thing is that while we're working on these demonstration projects, these collaboration projects, that can develop processes for going after fuels or chemicals or materials, we're also developing a lot of technologies. That could be software, it could be automation, it could be workflows, it could be genetic tools, all kinds of different things. And one of our core philosophies at the Agile BioFoundry is that any technology that we're using, especially during a collaboration project with industry or academia, those should be technologies that a given company or an academic can actually license off the shelf from a commercial company or license from us, so that they can practice those same tools and capabilities at home in their own organization behind their own firewall. So that's maybe one way of differentiating what a place like the Agile BioFoundry does, rather than maybe some of the more commercial biofoundries, where you might have a fantastic experience working with them, but you're probably going to want to go back to them as opposed to trying to repeat what you did with them in your own foundry, because you're probably not going to be able to bring in all of the same techniques and tools that are being practiced at a commercial biofoundry. Some other little things, and maybe this is a little bit just budget wonky, but I think it's actually pretty relevant for some of the people on the call to understand kind of how our budget and our resources are getting allocated, and how does that directly impact future types of collaborations. So the first thing is, for the past, say, 5 years, we've operated at a $25 million budget. So we at a $20 million budget. And then in the congressional budget language, we're anticipating our budget is going to be for fiscal year 2022 up to $30 million. So that's a bit of a change from us. And the way that we're breaking this down is we're going to be doing 23 on kind of like internally directed projects, and we're setting aside $7 million for collaboration projects. Now, that could include things like directed funding opportunities, and I think you're going to be hearing more later today about these directed funding opportunities. And 3 million of the 7 will be going into kind of the kind of what we've done in the past, these open directed funding opportunities that anybody can apply for, and I think you'll be hearing more about that later. But we've also been, prioritizing some of these resources for doing collaborations with others as follows. So we have been setting aside or prioritizing $2 million to collaborate with BioMade. And kind of the concept here is that BioMade could be supporting kind of its members and its participants. And the Agile BioFoundry would be using $2 million of our budget to work on our side in collaboration with BioMade. So I mean, just spend a little bit of time on this, but BioMade has been focusing and situating itself in slightly higher manufacturing readiness levels, say for example levels 4 through 7. But often in those projects, you will encounter kind of lower technology readiness level scientific or technical challenges. So we're thinking about different types of mechanisms for working together with BioMade. But for example, if a company in BioMade discovers they have a kind of a critical path low TRL that maybe the Agile BioFoundry would be very well situated to help address, then that might be a good example of how we use these resources to collaborate with BioMade. We're also setting aside $1 million to collaborate with investigators that are supported by the National Science Foundation. One of the things that we've been hearing loud and clear from academics is that it's actually very challenging for them to apply for our directed funding opportunities because of cost share requirements, because academic investigators are often supported by federal agencies, including the National Science Foundation. And those funds are really not something that they can use as cost share. So our current concept here is that the National Science Foundation could fund the academic group to do their side of the collaboration. And we would be using portions of this $1 million set aside to work on the Department of Energy Agile BioFoundry side of that collaboration. And then kind of a new thing that we're really excited about is also working together with the Minority Supporting Research and Development Consortium. And this is a slightly different model. It's still getting worked out. But whereas all of these other projects are basically resources or funds that need to be spent within the Agile BioFoundry itself, we do anticipate for the Minority Supporting Research and Development Consortium collaborators that some of these funds might actually go out and be spent at these minority supporting institutions, as opposed to entirely within the Agile BioFoundry. But I think it'd be great, for this listening day, just for people that are participating or thinking about participating in BioMade or NSF kind of PIs, or folks participating in the MSRDC. I think there's some real substantial priorities that we're making to collaborate with these groups in the next year. The other thing to really highlight here is that we've been excited ourselves, but also more specifically now directed by Congress to use a significant portion of our resources towards artificial intelligence and machine learning related projects. So within kind of our internal projects, our target is to have about $6 million spent relating to or supporting AI/ML, and then across all of the collaborations to have about $4 million kind of targeting or being related to AI/ML. So if you are thinking about putting in proposals through these collaborations to work together with us, I would highly encourage you to think how can you best leverage some of these artificial intelligence, machine learning types of approaches as part of your solution to overcoming your challenge. Just because we are going to try to prioritize projects that are going to be leveraging those types of capabilities. So Phil, I think that's pretty much it for right now. I probably went a little bit long.
Yeah, but no, you did a really great job in summarizing very efficiently the operations of the ABF and giving a sampling of how diverse our approaches are and how we might interact with industry. So thank you for that. But I did want to bring up a couple questions that came through the chat. And I think it'll be up to you to think if it's worth addressing now directly, or if you think an upcoming slide in a future presentation will handle it well, you might be able to handle it then. So specifically more on how long a typical onboarding process takes. Here it was directed at, say, a cyanobacterium. And then if you can elaborate a little bit more on, just how will the BioMade interactions happen? I know that's still developing now, but if you can talk briefly to that, I think that would be helpful.
Yeah, I can speak to those two things specifically. So in terms of onboarding, that's a great question. It's really going to depend on the current state of the art with that given organism. It's actually entirely possible that we can rapidly onboard it because that host has already been sufficiently, developed. Like it already has a genome sequence, it already has genetic expression tools, it already has replicating plasmids, ... So some of it can be, dependent on the particular organism. If you are interested, and I see that question is coming from Milan, feel free to reach out to us with any specific, organism, and we can have a follow-up with you to have that type of an assessment. And then, yeah, so the next question from Tom is about the money set aside for BioMade. So for this money set aside to collaborate with BioMade, all of that money is going to be spent at the Agile BioFoundry. I don't suspect that it's going to be able to be used as matching funding per the BioMade, types of, cost share matching funds. But as Phil was mentioning, we're actively working together with BioMade, and actually CLEM is on the participants list, and there might be others associated with BioMade too. So I think we're actively figuring these things out. But what I can tell you is I suspect not, but I think it's still to be determined. And then
the last one, Nathan, I think can be handled maybe after capabilities and maybe in follow-on discussions, because it's a really great question, and direct them to, first of all, our web pages, and then we can go into discussion thereafter about what assets really are being developed by the Agile BioFoundry and the artificial intelligence machine learning area. So feel free to handle it how you would.
Exactly. Yeah, I think so. Farhan, thank you very much for that question. And yeah, I think we'll go through some of the capabilities. It's probably not going to be entirely satisfactory because it's very deep. But as Phil was mentioning, I will point you to a capabilities web page where you can kind of dive a little bit more deeply. And eventually, when we do have these calls that'll be announced probably in the January or so timeframe, we will be having some webcasts that kind of give you like a quick pitch, like almost an elevator pitch for these different capabilities too. But certainly we can have more follow-up conversations about that. But I hope that at least you'll get a taste for what some of those things are after the next presentation.
Okay, great. We got one more.
Okay.
Now that might be good to wait on that one. We have a couple industry-directed project talks. So I'll read this a little bit more as Nathan starts his next presentation and see whether or not that can be handled later, or maybe Nathan at the end of his talk.
Felix, thanks for that question. I think maybe during Robin's talk that can be talked about. It's certainly possible, I would say. So yeah, but hold that thought, and I think maybe Robin can get to it, or we can ask it again once Robin.
Yeah, I think James will actually have some examples though too.
Sure.
Yeah.
Okay.
Okay.
I'm gonna go ahead and share my screen again.
Okay. Thanks, Nathan.
Yeah, I'll change presentations here. 1 second. Get back to the beginning.
There you go.
And again, I'm not going to be able to see chat or Q&A, but worked for the previous presentation. And again, Phil, start reminding me if I'm running out of time or running long. I'll try to go fairly quickly through these. Yeah, just ping me if I'm going too long.
Okay.
So the first thing, and Phil mentioned this, and I think it'll probably even come up again in some of the other presentations, but our website for the Agile BioFoundry in general is just agilebiofoundry.org. And in particular, there is a capabilities section that you might want to check out. And it's largely organized into design, build, test, and learn. As I was mentioning kind of in the previous kind of presentation, we do also have very helpful capabilities around techno-economic analysis, life cycle assessments, the host onboarding and development types of activities. And so we have, it's probably a little bit, broader than just design, build, test, and learn. But that's just kind of an easy way for us to kind of structure some of the capabilities. But I think what I'm going to probably do for the next few slides is I already kind of touched a little bit about our beachheads and metabolic cartography and host onboarding and the tier system, TA, LCA. So I think what I'm going to do is kind of focus a little bit more on the core DBTL cycle. And I think what I'll probably end up doing is kind of start at the interface between learn and design with art, and then I'll walk through kind of the cycle. And again, this is not exhaustive. There's definitely things that we're doing or capabilities that aren't going to get mentioned. I'm certainly not going to do justice to any of the ones I'll be presenting, but I think it's at least just going to be kind of like a quick taste of representative, types of things that we have or that we're doing. So again, you can follow up with us if you have any questions. So kind of the transition between learn and design, one highlight would be our automated recommendation tool, which has recently been published in a couple back-to-back articles in Nature Communications. And this is a non-mechanistic model. So it's almost kind of like, data type agnostic. But you can provide it, certain, types of input variables. So maybe there's things that you might be able to control, like media compositions, or, maybe you could, manipulate things like, how much a given enzyme is getting expressed. And you also provide it with kind of what was the consequence of that particular combination. So, for example, how much of a given, molecule did you produce? And it can use probabilistic predictive models, which very importantly can have confidence types of intervals associated with it, and it'll give you recommendations for the next set of conditions or genetic modifications you should be trying. So typically what you might have with this tool would be something like you have in gray you might have your set of data, you train the model, and then you make some recommendations for the next things to try. And then, at least in our experience, what's generally happens is, some of the new predictions actually get you to places that were much better than what you had before. But like any of these types of things, your predictions aren't all going to be perfect. So you still want to do several of them. And over time, if you do this iteratively, then you can increasingly, exploit and explore your space to come up with better and better strains. In terms of kind of like, the transition more between design and build, we do have our DIVA platform, design, implementation, validation, automation. And some of the things that we've been doing here is we've been working on things like, for example, trying to better understand how efficient we are at different stages in the build process. So where are we spending our time? Like how much is actually going through each one of those unit operations for each one of those steps? How much are we spending on labor, on instruments, on consumables? So we're just kind of having a better analysis, which I think is going to really try to help us understand where to prioritize our future work, as well as to understand how much value things like, for example, automation or new methodologies are actually contributing. So some exciting things in that space. In terms of sequence validation, just kind of a general capability if people are building new plasmids as part of their work. We do have kind of like a next gen type of a sequence validation workflow where you get full coverage of your plasmids. There's no it's not Sanger, there's no oligos required. We're doing about 1536 DNA samples per week. So that's kind of gives you an idea of kind of the throughput. Some of the things that we're continuing to work on would be automating the process more with some of the mini preps, for example, making it easier for users to really understand, are there SNPs in my plasmid, are there not? Looking for things, especially for genome resequencing. So if you've done an adaptive laboratory evolution experiment, for example, there might be some biases in the Nextera kits that we're using. So we're looking for alternatives. We've been seeing recently, it's actually really important not only to do your sequence validation against a reference, but especially for adaptive laboratory evolution types of experiments, it's really important to do de novo assemblies because you might miss really big rearrangements or insertions otherwise. And another thing that's been really powerful, I think, is that some of the DNA synthesis vendors now are selling these pools, oligos, so that could give you, variants in guide RNA targeting sites or variations in promoters, ... And oftentimes after you have those libraries into your host organism of interest, you might want to do screens or strains. We've been working on some sequencing pipelines for detecting some enrichments or depletions of specific variants, which can be pretty powerful to tell you what's happening. In terms of automation, lots of automation, both kind of on the build side, and examples would be transformation, but also on the test side. And this would be largely around some of the sample preparations. But also even trying to automate, trying to assess the quality or control for the quality of our data. So it's not sufficient that you have a lot of data. You want to make sure you design your experiments so that learn can actually learn, and you want to make sure that they're going to be high quality data. So also kind of automating some of those pipelines. Multi-omics analysis, again, lots of different techniques that we can use across proteins and genes and metabolites and lipids and sample prep that comes with it. And also just as building out infrastructure, we're accumulating over time lots of different data sets for these different organisms. And these can be very powerful, ways in terms of transfer learning. If you already have a strong background of information about an organism, then each additional experiment, that you do in that system can leverage those past learning. So that's also very, very important. In terms of biosensors and flow cytometry, we definitely have sets of established sensors. We can work on new sensors. These might be going after your target molecule. It might be going after an intermediate. You might have different dynamic ranges for different sensors. So earlier on in a process development, you might be using something that's a little bit more sensitive, and later on, when you're getting to higher titers, you might go to a slightly lower sensitivity, for example. But lots of interesting things around there. And very similarly, instead of just doing flow cytometry or kind of plate reader types of things, we also have some really cool capabilities in microfluidics and droplet microfluidics in particular, and even scaling down adaptive laboratory evolution into droplets. So lots of interesting capabilities on that space too, and not just kind of transcription factor based biosensors, but also some of these FRET based biosensors. In terms of scale up, I think this was a something that really is a big deal for us, and we're extremely fortunate to have access to lots of different scale-up instruments. And just on the screen here is basically a list of some examples across our national lab facilities. So we can get fairly large. I wouldn't say that we typically run things this large, but we can. So say, for example, up to almost 10,000 liter scale in Colorado. We also have kind of at a smaller scale, we're fortunate to have access to kind of the Amber 250 system. We also have some of the biolector, types of systems and other types of fermentation instrumentation as well. So we do have a lot of capabilities on the scale up side. Now transitioning more from like test to learn, we've definitely been developing over the years our experiment data depot, where you can basically feed in a lot of different experiment modalities, and then basically have that data in a structured standard way that really facilitates access from downstream learning capabilities, whether it's mechanistic or artificial kind of intelligence machine learning. So over time we're supporting in increasing types of experiment modalities. So we're supporting now the Amber 250, for example. Just as we talked about with DIVA, we're trying to get some estimates now of how long things are taking, and what types of throughputs we're getting in different test unit operations, and various other types of improvements. But this is a thing that really kind of enables us to work as a foundry. We've been working a lot on the mechanistic side, not just on the kind of AI ML side, but developing and validating metabolic models for our various host organisms, as well as kind of the ability to integrate across multi-omics data sets and to visualize those into actually actionable types of suggestions. We've been looking into, again, it's kind of like getting in between the mechanistic and just the machine learning types of approaches, but still probabilistic types of methodologies. But more of a probabilistic, type of a way to suggest to you, for example, in terms of like the flux control coefficients, which would be the enzymes that you would really want to target, and what are kind of their confidence intervals for if you were to overexpress an enzyme, like how would it impact your production. And then we also have if art is is kind of like maybe a more typical machine learning type of an approach. We also have the potential to do actually deep learning types of models. So multi-layered types of learning with some really interesting predictions of things that we wouldn't have intuitively have come up with. So some really nice capabilities there too. So again, I've only touched upon a few of the capabilities. I haven't really given any of them true justice. Please do follow up on the capabilities page and follow up with us if you have any other questions. Yeah, so I'll leave it there, I think, Phil, and I will stop sharing.
Yeah, thanks, Nathan. We don't have a lot of new questions, but I think it sort of emphasizes the fact that they want to know more about how to interact with us. But maybe before we go there is a chance for one short poll that the management is on the hook for a milestone, or host onboarding and development is on the hook for a milestone, and might want to capture a little more data on the breadth versus depth issue in bringing on new hosts to work on. I'm wondering if you wouldn't mind talking through this poll, if we put it up and get some more information on this, or should we move forward? Is that okay?
That sounds good to me.
Okay, Emily, if you wouldn't mind putting up the second poll, please.
So Phil, you would like me to read through it? Is that what you're saying?
If you would, provide a little more background based upon some of your early slides.
Yeah, so I guess in the overview presentation, I was showing this time trajectory of how many hosts we were expecting to be able to work with over time. And after the first 3 years, it was 5, and maybe after this current year, it'll be 15. And the question is, do we really want to go up to supporting 50 different host organisms, where they might be all at tier 1, but I mean fairly basic limited capabilities? Or do we want to maybe do, say, for example, like 20? So not really greatly increasing above the 15, but really going deep into those 20. So really trying to escalate, the tier capabilities of that 20. So I guess that kind of is the question. Now, what I imagine people are going to say is, well, if you're supporting the organism that I care about, go deep, because that's all I care about. And if you don't happen to be supporting my organism, go broad so that you do cover me. So it might depend on people, but that's kind of the tension that we have. We're going to have a fixed number of resources, and should we be directing those deeper for tier elevation, or should we be going more broad so that we can go across other organisms of interest?
Okay, great description. So thanks, Nathan. We'll just give a few more seconds for this, and maybe at the same time we can have Robin get prepared for her presentation.
Sounds good.
Emily, can you see how we're doing on the responses?
Yeah, we're about at 70%.
Okay. All right, I think we're probably good. Let's go ahead and call it, and let's see what the results are real fast before we go. Oh, okay, that's what we've been seeing before in other surveys that we've implemented. So we're sort of split down the middle, and we'll evaluate that further as we go and take that into account. So thank you very much for participating. Go ahead and close that. Great. So our next speaker is getting more into detail about the different mechanisms that are available for working with Agile BioFoundry. And so Robin Johnston is going to be giving this presentation, and we welcome you here to Industry Day.
Thanks. Can everyone hear me?
Yes.
Okay.
Sounds good.
Okay, great. Well, we'll jump right in. For some reason, my slides are not forwarding. There we go. Whoops. Okay, we went too far. Here we go. Okay, so there are basically 5 types of partnerships with the ABF. The most common that we've kind of addressed already is the direct funding opportunities. And I'll say more about that, and you're going to hear more about that from James as well. So I'm not going to get too deep into how you actually apply for that, but more if you do actually get awarded, what the consequences are. Basically, which is that we will put in place a special ABF cooperative research and development agreement, and I'll talk more about that agreement. There, and as Felix was asking, yes, projects can be funded directly by companies. with private funding or non-federal funding, in which case we could use a strategic partnership project agreement or a CRADA. And this is the model CRADA from DOE, which has not been adapted to ABF. And then there's just the informal transfer of materials, data, information, et cetera, that we can put MTAs and NDAs in place for. And then there's equipment loans, but I'm not going to talk about equipment loans because I don't think that's what you're here to talk about. So let's talk first about the most important section right now, or the most important contract, which is the Department of Energy direct funded opportunities. This is where ABF, the companies work with ABF to develop a proposal in response to the DOE DFO. And you companies can work with either one or several of the ABF labs, as I think Nathan already pointed out. The funding is provided to the ABF labs to conduct the statement of work, and the company provides a minimum 20% match. And that can be in kind, personnel time. We've even had licenses for strains count as in kind, cash, or a combo of the above. The awarded proposals are conducted under a DOE contract called a Collaborative Research and Development Agreement, a CRADA. And due to the extremely long CRADA negotiation times in the past, I think it was the first year or two when ABF first had these funding opportunities, it was taking many, many months to negotiate the terms of the CRADA. So what we did is we came up with a ABF specific CRADA that's used for all the ABF DFO projects, not for those projects that Felix was asking about that are funded by companies alone, but anytime there's federal funding or DOE funding, the special ABF CRADA will be used. We tried to come up with the best model terms that we could offer based on DOE restrictions. And I'll tell you a little bit about those. First of all, the ownership of biological materials. So often ABF is going to receive strains from their partner company or parts of biological materials. Typically under a DOE CRADA, those will, the new materials that are produced, not the ones provided by the company, but anything that's new that's produced under the scope of work is owned by the DOE labs. And that leads to a complication because then at the end of the project, we had to figure out, does the company want these materials that we've developed? They're probably already inserted into materials that the company owns. So we said, you know, what the heck, we would like to, at the end of the project, whatever biological materials are left over, we would like to have those split between the labs and the company, the participating company, and whoever requests those materials, if they're distributed to the parties, you automatically get title to those materials. No other agreement needed. They're just split if the company is interested in having them, and the company takes title and can do what they want, provided that there is the IP that accompanies those is properly also transferred. So this, again, does not mean that a partner DOE lab would take title to any of the biological materials or the parts provided by the company for the project. Those are provided to ABF under a separate MTA. Only the materials created under the scope of work have the shared ownership. So that's actually we had to fight for that with a little bit to get that term, but I think it simplifies things. Now, Nathan already talked about how ABF sees itself sort of as BART, or as a public infrastructure that then leads to specific products and companies taking the technologies further to develop products. So we're very focused on, so my analogy is just, you know, the rising tide lifts all boats. ABF wants to improve and help companies in the bioeconomy more broadly. You know, the tools for engineering non-model microbes are usually useful broadly, and they can be platforms. And the platforms to accelerate DBTL can be very broad. DOE also wants to maximize the use of the technologies developed with federal funding. On the other hand, we are very aware that companies need IP to actually ensure their investment, that that they're going to actually make in producing a product. So we want to also give you some gas to get your project out of the harbor and get you some long-term confidence that you have some protection in competitive waters. And we have thought very hard about how to balance these two needs, which are not exactly harmonious all the time. So what the DFO CRADA offers is two options for options. And if you don't know what an option is, some of you may not have negotiated IP terms before. It's basically reserving a license. It's sort of a placeholder for an ultimate license agreement. So under the CRADA, IP ownership follows inventorship. The labs own what their employees invent, the company owns what their employees invent. Joint inventions are jointly owned. For lab-owned inventions developed under the DFO scope of work, company can choose between two IP license options. You can either get a 6-month no-cost option to an exclusive license in a defined field of use with reasonable terms, and we usually don't pre-negotiate the licensing terms, but we're obligated to offer reasonable terms. Or you can get an 18-month no-cost option to a non-exclusive license in all fields of use with reasonable terms. So for the platform technologies, we really are trying to incent people to maybe choose the non-exclusive license, especially if they don't know what their particular end product is going to be. Maybe you're developing a host organism and you're not sure what your end product will be. Then you can get the non-exclusive license, and we can also offer that to other people, other companies that might be developing things in that host organism, as an example. If you really, really need exclusive rights, we are probably going to hold you to a defined field of use that makes sense for your company, that allows your company to have the IP terms that it needs for products that you have or are contemplating seriously, but not something that you're just contemplating broadly, I would say. The company has 45 days from the time the lab-owned invention is disclosed to the tech transfer office to select which option it would like to take. If you know you want one or the other, you can, upfront negotiate the field of use, if your choice is for the exclusive license. And this new CRADA is kind of an experiment. We really are open to your feedback and your ideas about how you think we could best balance those two, those goals. We're open to other structures. And we want to innovate in tech transfer, and in this area within the DOE requirements, which are quite complicated sometimes, but we really do want to innovate in this area as well as innovating in the sciences. So let's move on to the idea of if you just want to skip the DFO process and you really want to just fund ABF directly based on something that your company needs to advance, you can partner with the ABF using non-federal funding under a negotiable CRADA or a strategic partnership program agreement. Like I said before, the DFO CRADA is non-negotiable because of the time it takes to negotiate those in the past. But if you're actually funding a CRADA, then you get to negotiate it. So what's the difference between an SPP and a CRADA? An SPP is usually a shorter term project that's unlikely to generate IP. Usually the company owns the background IP and they want ABF to perform some well-defined work. If the company is, it's strange that it's called a strategic partnership program. Frankly, DOE names it that, but it's usually actually more tactical. CRADAs are usually more strategic, but anyway, name aside, if the company is US majority owned, the company will take title to any lab generated inventions. So that's an advantage over the CRADA. The company would actually, if you happen to develop IP at the lab, then the company would take title. If you're not US majority owned though, the labs take title and they may choose to offer some limited licensing rights, but that is going to be subject to DOE approval. Under an SPP, the company also provides the labs with general indemnity. I know some companies have actually chosen the CRADA because of that. But anyway, so A CRADA is actually a true collaboration and joint problem solving. The company can also embed employees at the lab, whichever lab you're working with, which you cannot do under an SPP. IP ownership follows inventorship, but again, the company gets an option to an exclusive license in an agreed upon field of use. Now you can, the company may choose, they may get the option to the exclusive and then ultimately say, we don't really want an exclusive. We don't want to pay for an exclusive. We're fine with the non-exclusive. So you can also choose that. And there's no general indemnification under a CRADA agreement. We also welcome these informal collaborations for the purpose of sharing materials, data, information. Nathan and Phil have mentioned how we try to talk with industry to get feedback on what our future projects should be. And I know the researchers and especially the strategic leads in ABF have a lot of contacts in industry and they want to keep engaged with you. Anyway, so we can have those under no agreement at all or NDAs or MTAs, and happy to get that. We also might want to put those in place to plan future projects. So what are some of the non-obvious benefits of working with ABF? I think people maybe underplay these in some ways, but I've been at the Berkeley lab 20 years now. As I was reminded today, I got my 20-year pin, which kind of just makes you feel old, but it also makes you feel like you've seen a lot. And I will say that people working with the more applied side of the labs, their platforms are very well informed by industry needs. They provide commercially relevant results. The IP that comes out is very practical and it has a very strong branding with investors. If you're a startup company or a mid-sized company and you're still looking for investors, the DOE labs, have very strong branding. So you may have to actually initiate a license, and our license terms, by the way, our goal is to get a fair return for the taxpayer, not to get every penny off the table. It's to get the technology out and used and get a fair return, not an optimized return necessarily. Also, you build positive reputation with DOE and the participating labs when you have a successful project with like the Agile BioFoundry, the ABPDU, or any of these other more applied programs. If you have a successful project, to be honest, you're going to be looked upon more favorably in the future, or I wouldn't say more favorably. You will be looked upon favorably if you have a strong proposal in the future because you're building a reputation for making good on what you've done with the labs. Also, the CRADAs can provide excellent staff training opportunities. Just as an example, the Joint Bioenergy Institute has had a partnership with Total Gas and Oil for, I guess, 11 or 12 years now, and they have located 1 or 2 researchers at in the same facility that ABF is located in for that long, and it's been a fantastic collaboration. They've trained people, they've advanced people, and they're definitely building their biology. They've built their biology program on some of that training. The other thing is you get exposure to these cutting edge tools that you may decide that you want or don't want based on your interaction with ABF. So you can make more informed purchasing decisions in the future. So just some extra benefit for your dollar. If you have any questions, feel free to reach out to me individually, or I hope you have some in chat. I am not able to see the chat again. I'm going to look right now, and I think I can stop sharing my screen.
Hey, Robin. So I guess and Felix, feel free to jump in if you want to ask it yourself. But one of the questions that came up when I was presenting is, so you discussed kind of maybe in the context of a DFO, how some of the requirements or terms are dictated by a non-negotiable, type of a CRADA. Can you talk about how that might be different, either as a subcontract if we apply together for a federal kind of a funding project, or if the private company just pays for the whole project?
Okay, so I meant to cover that in one of my slides. The idea that if the company pays for the whole project, you can definitely negotiate CRADA. it's negotiable. The IP, you automatically by statute, by congressional statute, you get that option to a 6-month no cost option to an exclusive license in a field of use. But we can, if you're paying for that, you can negotiate things having to do with price of extending an option. Berkeley Lab often does that. If you're like 6 months isn't enough, we can negotiate that, the terms for that. Usually with Berkeley Lab, frankly, it's about $5,000 or $6,000 to extend your option for a year. We can negotiate how the payments are made, how often the payments are made. And you will have a scope of work also in that CRADA. Unlike, with a DFO, you will have a scope of work that's in kind or meeting that 20% match, unless you just pay cash. But under the CRADA, it's important the company has a scope of work and the labs have a scope of work. So Nathan, are there other specific things that you wanted me to address?
No, I think that's pretty good. I guess if Felix wants to jump in again with any follow-ups, but yeah, just the distinctions about kind of the DFO uniqueness versus something that's fully paid by the company, and then the contractual differences between like a company supported project versus if we're just kind of like, jointly applying for a federal grant. So yeah.
Yeah, I would agree. I think, Robin, you did a great job. We're really blessed to have someone with this understanding that could take a relatively confusing topic and sort of unravel it for us and present it in a way that's really digestible. So I thank you for that. And I would encourage you to go to the question and answer feature of Zoom, because there's a couple directed to you there, and maybe follow up with Felix in the question and answer, because some of that may be answered a little bit more when we get into James' presentation, who is going to be talking about how we've engaged with industry through our directed funding opportunity. So if that's okay, we'll just go ahead.
Yeah, great. I will write anyone back. You can write me in the chat and I'll happy to respond.
Yeah, chat or Q&A, because there's one in the Q&A too.
Oh,
so.
okay, great. Yeah. Oh,
yeah,
sorry.
they're separate in this webinar series. Yeah. Okay. Thanks again. And James, you're on. So we're looking forward to your presentation.
Okay, great. Can everybody see my screen?
We can. It's in editing mode, but you're really close.
How about now?
There you go. Perfect.
Okay. So I'll probably gloss over a bit of the detail that I have prepared, just in the interest of time, and try to focus on the things that I think you'll find most interesting. So the directed funding opportunity. This is a funding opportunity that the ABF has been running for 3 years, for 3 fiscal years over its 5-year history. And so, the goals of the directed funding opportunity are really just echo what Nathan kind of talked about, of deploying ABF's capabilities in order to accelerate the commercialization of bioproducts, to augment ABF's capabilities in an industry responsive manner, and to kind of, as a nod to the Bioenergy Technology Office's strategic objectives, to essentially decarbonize the industrial sector, part of which is developing sustainable biofuels. So just by way of project history, so far, the directed funding opportunity has accrued about $15 million in DOE funds over its 3 fiscal years of execution, with a minimum 20% cost share. That has resulted in a total of 21 projects. 7 projects were awarded in 17, 8 in FY20, and 6 in FY21. So very high level process overview, and I'll focus mostly on the applied part for the industry kind of input of the process. So there's some planning that takes place, of course, where we work to understand what worked well, what didn't work well in past DFOs. We apply that so that there's this continuous improvement kind of paradigm that we always adhere to. Then the application process itself is one where the prospective applicant would essentially describe the project that they envision in a brief abstract, and then join a kind of a speed dating coordination call where they would have a few minutes to describe the project further, and then the 10 or so Agile BioFoundry lead investigators would have an opportunity to kind of describe their capabilities and specifically respond to the project description and the abstract. And so from that, we would then move forward to a selection process where external reviewers who have been carefully vetted for their lack of conflict of interest for the applications they're reviewing would give us their expert opinion and recommendation and score and rank those proposals. And then the selection committee of the Agile BioFoundry would then select from among that top ranked group in order to sort of have a nice balanced and strategically selected portfolio of projects. Then there would be an agreement process, and of course, Robin went into some depth with regard to the cooperative research and development agreements, and so that process takes place, and then the actual research kicks off from there. So far, we have worked with 21 across 21 individual projects and something on the order of 22 or so different groups. Sometimes they come in as pairs of collaborators. So we've really run the gamut in terms of the types of companies we've worked with and the types of projects that we've initiated. The DFO participants have really used the full breadth of ABF's capabilities. There's no one area that they seem to go to over and over again. Design, build, test, and learn. The entire kind of DBTL cycle is something that groups utilize routinely, not to mention the kinds of other areas, these sort of supportive ancillary areas that Nathan alluded to in terms of techno-economic analysis and life cycle analysis for understanding economic feasibility and impact to the environment, as well as translating that technology to scale and sort of climbing the technology readiness ladder. Kind of in the bargain, these projects have resulted in quite a bit of augmentation to ABF's capabilities in the realms of, just by way of example, host onboarding, where groups like Caverdi and Basolis and others have really contributed to our ability to bring on new non-canonical hosts. Various modeling and bioinformatics capabilities have been augmented through our collaborative efforts with Agilent and Lagos and quite a few others. And the DBTL cycle itself has been grown more efficient by virtue of the fact that we're simply turning that crank more frequently and studying how we achieve even more efficient results across that cycle. So the FY17 DFO, as I mentioned, had 7 proposals. It had 7 proposals that were awarded, rather. 19 proposals were submitted, and so that translates into about a 4-fold oversubscription at about $19 million requested. So that was our first foray into the directed funding opportunity, and we learned quite a bit, not the least of which was the idea of generating a non-negotiable credit in order to speed things along in that part of the process. So I'll just hit a couple highlights. One of which is that in that first cohort of directed funding opportunities, we had Lagos, which used that collaboration to advance their isobutyrate platform, and so that's obviously a methacrylate kind of compound that is used in a wide variety of products, obviously for plexiglass and so forth. And so they were able to advance that platform of theirs by a 20-fold increase in titer in a matter of 2 years. And so that was something that we were excited about, and of course, Lagos was quite excited about. Secondly, from that first cohort, we worked with Teselagen and integrated with Teselagen's synthetic evolution platform across a variety of tools from ABF. And in doing so, we were able to publish high impact publications, and Teselagen was able to kind of leverage that for inking new deals with other groups, including from LonzaTech. Kind of staying with the LonzaTech theme, LonzaTech themselves partnered with the Agile BioFoundry and in developing AI models, which were successful in recapitulating human expertise for identifying stable continuous fermentation regimes. And so this was extremely important for them to be able to deploy their technology to new and sort of nth scale factories across the world. And so they continue to develop these technologies. The FY20 DFO is now off and running, and that had 8 proposals awarded across 17 applications that were submitted. And so that translated into a 2.4-fold oversubscription of our DFO. And again, just to hit a few highlights, C16 Biosciences has the goal of leveraging ABF's onboarded host, that's arterioides, to accelerate biomanufacturing of its mid-chain fatty acid platform, which is essentially a palm oil alternative. Let's see. And then Endurogenetics is another one. This is a group that has developed a product addiction technology in E. coli, and they're quite keen to then translate that into other more commercially relevant hosts. So they'll be working with LBL, NREL, and Los Alamos on this project for identifying paths to reducing heterogeneity and onboarding of new hosts. So they'll be working with B. subtilis as well as ABF's Corynebacterium glutamicum platform for mucinate production. And finally, the most recent FY21 DFO resulted in 6 proposals, and for that there was about a 3-fold oversubscription from the 17 proposals that were submitted, and the 6 that went forward include from Technology Holding, Teselagen, LonzaTech again, Levadura Biotech, Industrial Microbes, and Hue. And so just to give a very quick overview of those projects, Hue is in the business of creating an indigo dye production strain, and Industrial Microbes is very interested in gas fermentation and marrying that to various AI models. LonzaTech wants to move forward a little bit more aggressively with its Clostridium platform for augmented genetic tools in that organism. Levadura Biotechnology is working in triacid lactone production. Technology Holding is adipic acid, and then Teselagen Biotech is interested in deploying AI for community-generated data. So those are the 6 projects that are moving forward most recently. So the DFO impact really comes down to serving as a successful mechanism for deploying Agile BioFoundry capabilities directly to industry to solve its toughest challenges. The DFO really supports ABF's strategic goals in that way, and so there's a great symbiosis that is created by virtue of the DFO. And then finally, the DFO really serves as a valuable vehicle for industry engagement, so that we can continue to understand the kind of ever-changing needs of the field and really respond to that in the most agile way possible. So with that, I will take any questions.
Okay, thanks, James. That was a great overview. I didn't see any obvious questions in the chat, but we'll give it a few seconds here to see if anyone has something specific related to the presentation. And I'm sure Nathan would want to maybe hit back to Felix's question. Do you think it's covered enough already, Nathan, or should James handle that a little bit more?
Yeah, I mean, I think Robin also responded in chat to Felix. So I think Felix is in pretty good shape. Yeah. So I mean, I don't know if we get another question, we can certainly pitch it to James. But is there, James, and you might have already done this to an extent, but anything that you want to tease the audience with in terms of when we'll be announcing the DFOs, what to expect in terms of coordination calls or webcasts or anything like that?
Yeah, it's one of those things where I don't want to necessarily reveal some of those details until we've had an opportunity to fully bake them. But I will say that we're very excited to be looking forward to another directed funding opportunity that will likely drop in the late January timeframe, maybe February, depending. And so it will definitely take place. There will probably be some process improvements that we implement in order to make the external review process a little more robust, as well as the upfront sort of coordination call process a little more robust. So we're as Nathan alluded to, we're now working with a variety of groups and really excited to kind of be diversifying our funding opportunity portfolio, as it were. And so that will require us to think really hard about how we manage all of that so that we can be as responsive as possible to the community. And so we've been playing with some ideas, and some of that is kind of in the oven still. And so we'll be really excited to share that with you in the very near future.
Very nice. Thanks, James. That is exciting. It's a really fun time of year to start the new process and get a feeling for what's out there as a pain point in industry and see how we can help address that. So it's really cool. I think Nathan and James, I'm going to flip it back to the audience just for a second with our last poll. We have, described a wide range of topics today, from, what are we, to how to work with us, to how have we worked with companies successfully in the past. And we're interested in getting feedback as to what would be most helpful if we do this in the future to highlight a little bit more extensively. So we put our last poll up, and it lists out, our different topic areas for today. And if you wouldn't mind just voting for us as to what was most helpful and what you would like to see more of in the future with your response, we would appreciate it. There we go. Thanks, Emily.
And while people are doing the poll, just to note that Jackie put another question into chat, and I can kind of give maybe a first pass at that. And again, for Jackie, this might not be totally satisfying, but we can maybe discuss more later. If industry comes to us and they want to work with E. coli, then that's fair game. We have existing, and precedent DFOs for actually working with E. coli, for example. Generally, we're probably going to prefer, all else being equal, to use the other organisms. But if there is industrial need and they have a strong use case and a reason, then I think that's perfectly fair game. In terms of cell-free, I think it's just going to depend on. We generally want to enable biomanufacturing. So we just want to make sure that we add value. So we don't have a lot established ourselves yet in cell-free. That might be changing over time. But for example, if you wanted to use analytical methodologies or learn methodologies or TEA, LCA, or all those types of things, I think that's also completely fair. In terms of the application space, some of the therapeutics and diagnostics can be more challenging for us to work on. It's not, I wouldn't say it's a no, but we would probably need to talk with you, and then also talk with the Department of Energy types of folks to see how it would go. And James, I don't know from your advanced biofuels and bioproducts development unit if you have anything that you want to speak specifically to Jackie's question.
Sure. So there definitely is precedent for us to work with companies on therapeutic compounds or precursors. So it's doable. I think what we would want to do is make sure that, all of our stakeholders are comfortable with that path forward. It's sort of new territory for the Agile BioFoundry. That doesn't mean it's not doable. It's just a measured response. So I think it would require us to evaluate that.
Okay, thanks. Emily, would you like to flash out the results? Okay, more. Yeah, I was expecting that. So more on how to work with ABF and highlighting Robin and others as to how detangle those agreements, which at times look complicated. So totally understand, and we'll take that seriously into account for future presentations. As we're wrapping up today, I just want to take the time to thank all the presenters today who took time to generate the slideshows and give their presentations. So Nathan, Robin, and James, there's a big thank you that goes out to you. And last but not least, we thank the attendees today to come and learn more about us. We want to direct you to our webpage, agilebiofoundry.org, if you want more information. And there's ways, many different types of ways to get a hold of us if you want to know more. So please don't be shy. We're really interested in talking to you, and we're here because of you. And we want to continue that interaction and collaboration going forward. So thanks again, and we look forward to seeing you at future events like this.
Bye, everyone.